This is section 12.3, dividing polynomials. First, we're going to look at dividing polynomials by a monomial, that is, dividing more than one term by one term. Here you have two options. You can either divide it as a fraction or you can do long division. The first option is dividing as a fraction, and this I would highly recommend because it's the easiest way to do it. If you look at this example, we want to divide 4x cubed plus 8x squared plus 10x by 2x. So what you want to do here is make three different fractions. You're going to divide each term by 2x, and then you simplify each fraction, removing all the greatest common factors. So what you end up with is 2x squared plus 4x plus 5. The second option is long division. Here we have 4x cubed plus 8x squared plus 10x. And again, we're going to divide by 2x. So we're going to do long division like you used to do it in 3rd or 4th grade. So we see how many times can 2x go into 4x cubed? And it goes in 2 times x squared times. So you put that term 2x squared on top of the 8x squared term, because you want to keep all your exponents lined up. When you multiply 2x by 2x squared, you get 4x cubed. So you subtract that out and then bring down the next term, which is 8x squared. Then you ask yourself, how many times does 2x go into 8x squared? It goes in 4 times. So you multiply 2x by 4x and you get 8x squared. And last, how many times does 2x go into 10x, this last term that you brought down? And it goes in 5 times. So your answer is 2x squared plus 4x plus 5. That's the same answer that we got above, right? It's just a little bit more difficult to do it this way. When you're dividing by a binomial, that is two terms, you want to consider factoring first. So you're going to factor your polynomial and see if you have a common binomial in the numerator denominator. And if so, then you're finished. But if you can't do that, you have to use long division. So in this case, we're going to look at this one. Divide x squared plus 2x minus 3 by x minus 1. So again, I set it up in long division form. And you look at how many times does x minus 2 go into x squared. It has to go in x times. So the first thing we're going to write up top is the x, and we multiply x times x minus 1 to get x squared minus x. Now what's really important here is to remember is that you are subtracting both terms. So you're going to subtract both, and you get bring down the 3x, and then bring down the next term, which is the negative 3. How many times does x go into 3x? It goes in 3 times. When you multiply that, you get 3x minus 3, and you end up with 0 as your remainder. This divides evenly, so there is no remainder. So your answer is x plus 3. When you divide, though, with a binomial, a lot of times it doesn't go in evenly. Your result is going to have a remainder. So in this case, we're dividing 2x squared plus 11x minus 9 by 2x minus 3. I use the same long division method that we used before. I multiply the dividing term by x, and I get 2x squared minus 3x. I subtract that out and end up with a 14x. I bring down the minus 9 term. How many times does 2x go into 14x? It goes in 7 times. I multiply that by 7. 2x minus 3 times 7 is 14x minus 21. And I subtract both of those terms. Don't forget to subtract both. So this then becomes a positive 21. So you have a remainder of 12. 2x cannot go into 12. So what do you do with that remainder? That remainder becomes 12 divided by the 2x minus 3. And you have to add that to the end of the term here. So your answer actually becomes x plus 7 plus 12 divided by 2x minus 3. Before you divide polynomials, you have to make sure that they're written so that the exponents decrease from left to right. If your variable terms are missing, you have to insert a placeholder with a coefficient of 0. So in this example, we want to divide 5y plus y squared plus 4 by y plus 2. But in order to do that, you have to rewrite both terms. The first one is y plus 2, and then you have y squared plus 5y plus 4. You see how those exponents decrease from highest to lowest. That's the only way to do this. Then you do the long division the way we've done it in every other example. So you might want to just pause this and take a look to make sure that you understand how I got y plus 3 minus 2 divided by y plus 2. The only thing that's different in this one is that the remainder is negative, a negative 2. So when you tack that onto the end of your answer, it's a minus 2 divided by y plus 2. In this next example, everything's out of order. You want to divide 13 by 4m squared by negative 1 plus 2m. So first rewrite the terms. So you have 2m minus 1, and you want to divide that into 4m squared plus 13. The problem is the 4m squared plus 13 is missing an m term, and you need an m term there as a placeholder. So you're going to insert a placeholder of 0m. So down here I have rewritten the problem so that it's 2m minus 1 divided into 4m squared plus 0m plus 13. So then we're going to divide. Again, you ask yourself the question, how many times does 2m go into 4m squared? It goes in 2m times. So multiply that out, subtract the terms, so we're subtracting everything that's here, 4m squared plus 2m. We end up with a negative 2m. We bring the 13 down. How many times does 2m go into 2m? It's one time, so we put a 1 up there. We end up with a remainder of 14, and of course that becomes 14 divided by 2m minus 1. Sometimes they ask you to graph these, and to graph y equals 2x minus 1 divided by x minus 2, you actually have to divide this out. You want it to be in a form that you recognize to graph. And there are only certain formulas that you know how to graph, right? A linear formula, a quadratic formula. Well, now you know the hyperbolic formula. That's what you want to graph. And remember, that is y equals a divided by x minus h plus k. When you divide these two binomials, you're going to end up with an equation in that form. So I divided it out using long division. It's really pretty simple here. The answer is 2. You've got a remainder of 3, so it's 2 plus 3 divided by x minus 2. You can see that is in our form. Yes, the terms are switched around in a different order, but it's exactly the same thing. So by looking at that answer, you can see what the asymptotes are. Y equals 2, because remember y is k, right? Y equals 2 and x equals 2, so you would drop in the asymptotes on your graph. And because the a is positive, because that 3 is positive, you know this hyperbola goes in 1 and 3. If you had to compare it to the parent function, what would you tell me? You would tell me that it shifts up, that it's a vertical translation, yes, and then also because it's multiplied by 3, it's a vertical stretch. It's going to be larger or wider than the parent function is. So you should be able to at least sketch those in so that you know where they're located, and be sure that you can drop those asymptotes.